Hey, good evening, guys. My name is Ganesh Shankar Bhandari, and I am here to take the live session for NPTEL course Principles of Extractive Metallurgy taught by Professor Tarun Kumar Kundu. First, we will go with the revision of the previous week lectures. Then, based on the previous week lectures, we will try to solve some MCQ type problems, which will help you to solve the assignment problems given to you based on the previous week lectures for this week. Okay, so first we will go with the revision of previous week lectures. So before this, in previous 2 weeks, we have learned about the different types of minerals, different types of physiochemical and physical processing steps to remove the gangue material from the different valuable sources. And then we have talked about flotation, we have talked about magnetic separation, electrostatic separations, and we have talked about the liberation side. So now in this week lectures, we will mainly talk about the sensor-based automatic ore sorting system, which is also known as the SBS process, and the condition required for SBS to work, and the effect of particle size on sorting output and operating cost of SBS. Then first we will talk about the sensor-based ore sorting process. Previously we have talked about the liberation size and we have talked about the grinding and crushing operations. Okay. So, and after the grinding and crushing operations, we have learned about the various physical beneficiation processes like froth flotation and magnetic separation, electrostatic separations. So now in this week lectures, we will talk about the sensor-based ore sorting processes. So sensor-based ore sorting processes, which is also called as electronic sorting or automatic sorting, is an umbrella term for all applications where particles are singularly detected by a sensor. So what we are trying to do, we are trying to separate them out on the basis of their physical structure, or we can say luster or color. So we have feed these all the datas in a sensor system, and we are trying to detect that particular minerals based on their properties with the help of a sensor and detected by an amplified mechanical, hydraulic or pneumatic process. So after picking up detecting up this the particular mineral with the help of a sensor, we are applying some processes so that we can eject them out from the overall material. So SBS is the automation of hand sorting, which is now extended by the use of additional sensing or detection technology. So preliminary, these things were done based on the automation of hand sorting. Then now they are using some sensor-based technology, detection technology. Like it is like simple, it is like purely an example of image processing. So what we are trying to do, we are creating the images of the particular ore source, and then we are feeding it into some sensors, and we are along with those images, we are feeding the physical data of the particular ore. Then based on those data, we are trying to separate them out. So automated sorting machines examine individual particles, compare the major properties of each particle with predetermined criteria, which we have already fed into the machine, and then separate the particles using an externally applied force into different products. So sensor-based sorting, automatic sorting requires four interactive sub-processes, which includes feed preparation and particle presentation, then the particle examination, data analysis, and particle separation. So sorting can be applied successfully only if the accept fraction is liberated from the reject fraction. So we need proper liberation of the particles, proper liberation of the mineral and gangue particles at the size to be treated by the sorting machine, and both fractions must be consistently identifiable by some means within the available examination time. So ore sorting examples and working spectral range. So those these things can work on different electromagnetic wave ranges like radiometric, radio waves, X-ray transmission, X-ray fluorescence, color photometrics, and the material properties of these things varies according to according to the material properties. We use the particular sensor type, like for if we have a material property like radioactivity or something like that, then we can go with the radiometric type sensor system, and we can apply it for the mineral beneficiation process of uranium ore or thorium source. Then there are reflectance and absorption properties on the for the reflectance and absorption property. We need to use the near infrared spectrometry type sensor systems, and these are generally used for the applications in as industrial minerals beneficiation. Then practical ore sorters and field size effect. So based on these different types of different sensor types and particular material properties, we can design our particular ore sorters and feed particular ore sorters with some mechanical systems. Then obviously there are some disadvantages of SBS process, like there are processing disadvantages which include sorter requires much feed preparation. Like we have to liberate the particular minerals up to a size which sorter can treat. Then sorters can treat only narrower size and sorter throughputs are low. Fine feed are not fit sorting because if we are going with a very finer feed fraction, let's say minus 150 micron, then the sorter will not be able to detect the material in the particular heap based on their physical properties or color or something else. Then there are some economic disadvantages, like sorters are expensive to install, then sorters are expensive to operate, and deposit is either small or big to warrant for sorting. Then some operational factors disadvantages are also there, like sensors are very difficult to maintain. So other pre-concentration processes are simpler and cheaper because they don't need much operational cost. So there are some separation method. There are some so based on the lectures, we can divide different separation methods like gravity separation methods, which generally include aquatic media or heavy media density separations. Then there are magnetic separation methods, which generally go like low intensity magnetic separation processes or high intensity magnetic processes, which can be applied in dry state or in wet state also. Uh, then there are electric separation methods like electrostatic separations and eddy current separators are there. Then free fall or high tension separators are there. Then there are physiochemical separation methods, which generally sort the ore on the basis of their physical properties, like flotation method or colloidal method. These are the types of the physiochemical separation methods. Then coming to the next lecture. So in most of the mineral processing in most of the mineral processing mineral processing steps or we can say beneficiation steps, we generally go with the wet processes, like we are using water system, because if we are talking about a size range of less than minus 150 micron or 200 micron, then it is very difficult to treat them in the dry condition, because there will be if we are going to treat such fine powders in dry conditions, then there will be very very high dust generations will be there, and we are going to lose some of the minerals or gangue particles in the air, and it will increase the ppm level, particulate matter level of the air quality also, and that can be hazardous for the humans. So now, before the beginning of these mineral beneficiation process, we are going to add some water inside the system. But what will happen when we are going to get that concentrate and gangue material? Okay, so then we have to remove that water from that concentrate or gangue material, so that we can go for the further processing operations. So for removing the moisture and water content from from these fine powders, we use different moisture removal processes like sedimentation, coagulation, flocculation, thickener, pressure filter, vacuum filter. or we can go for batch filtration process or parallel flow dryer. So we have to remove this water, or we can say these all processes are known as solid liquid separation or dewatering process. So most mineral separation processes involve the use of substantial quantities of water, we have already talked, and the final concentrate has to be separated from a pulp to get relatively dry concentrate for shipment or further metallurgical operations. So these dewatering methods can be broadly, generally classified into three groups. First one is sedimentation or thickening process that can separate up to 60% of the pulp water. Then there are filtration process like pressure filtration or mechanical filtration presses are there, which can produce 80 to 90% solid having 10 to 20% water content only. Then there are thermal drying processes which provides up to 95% solids by weight. So according to these dewatering process, like if we have 50 or 60% water in the pulp, so we cannot directly go for the thermal drying processes. We have to go step by step. Like first we will go for sedimentation or thickening process, then we will go for filtration process, or we can directly go to the filtration process. Then only we will be able to apply the thermal drying process after applying the filtration process. So we are going to remove major quantity of moisture, major quantity of the moisture from the sample before going for the thermal drying process, which can provide up to 95% solid by weight. So coming to sedimentation and thickening process, so settling of solid particles in a liquid produces a clarified liquid which can be decanted, leaving a thickened slurry which may require further dewatering by filtration. Because when we are talking about a pulp, okay, so obviously water is having a density of around 1 gram per centimeter cube. Then whatever the mineral is inside in that pulp, okay, if we talk about hematite, we talk about magnetite, or we talk about silicate minerals, those are always having a density greater than the water. So whenever we are uh, going to treat a pulp material and we are going to leave it for some time, okay, so what will happen, because of the density differences, the particles are going to settle down and the water will remain on the above side. So that process is generally known as the sedimentation process. So settling of solid particles in a liquid produces a clarified liquid which can be decanted, leaving a thickened slurry, which may require further dewatering by filtration methods, or after filtration method we can go for the dry separation dryers. However, the settling rates of particle in a fluid are governed by Stokes or Newton's law, like what is their free settling velocity. Uh, 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 Regarding this free settling velocity, we have already talked about in the previous week lectures. Uh, we were talking about the heavy media density separation processes, and we were talking about the uh, density based separation processes like spiral concentrators and jigging operations. So, depending on these are also dependent on the particle size. Very fine particles settle extremely slowly by gravity alone, and centrifugal sedimentation may have to be performed. So, if the particle size is on the very much lower size, so it is going to take very higher time for the gravity separation alone. So, we can expedite the process with by using centrifugal sedimentation process. So, the process can happen in shorter time duration. Alternatively, the particles may be agglomerated or coagulated or we can say flocculated into relatively large lumps to settle quickly by adding some chemicals during that sedimentation or thickening process. So that those chemicals or reagents can help in the coagulation or flocculation of these particles, and that can get agglomerated in a shorter time period and can get settled down quickly. Because if the size of the particle is going to get increased, or the number of particles are going to be in an agglomerated form, so the free settling velocity will get increased due to the higher particle size. So coagulation causes extremely fine colloidal particles to adhere to each other. All particles exert mutual London van der Waals attraction forces which are effectively on at very close range. So generally for the coagulation purpose, we can apply some external forces or with the help of some chemical reagents or polymers, so that this coagulation process can happen in a shorter time duration. Electrostatic coagulation is achieved by adding organic coagulants, which are generally polymers of molecular weight around 3000 to 1 million, with cationing functional groups for negatively charged surfaces. So before adding the chemicals, we need to analyze the surface properties of the particle which we want to be coagulated. So when a particle moves in the liquid, shear takes place between the bound layer, which moves with the particle, and the diffuse layer. The potential at the plane of shear is known as the zeta potential, which depends on the surface potential and the concentration and charge of the counter ions. So most pronounced coagulation occurs when the particles have zero charge in relation to the suspending medium. This occurs when the zeta potential is zero. So similarly, there are flocculation processes. So flocculation involves the formation of much more open agglomerates and relies upon reagent molecules acting as bridges between separate suspended particles. So here we are adding some chemical reagents which are going to act as a bridge between the two particles to get them agglomerated. The reagents used to form the bridges are generally long chain organic polymers which are were formerly natural materials such as starch, glue, gelatin, and guar gum, but are now increasingly synthetic materials like polyelectrolytes or polyacrylamides are extensively used as a flocculant material. Then there are some thickeners or thickener types like centrifugal or gravitational process. We can expedite the process of the settling behavior of the particles inside a liquid medium. With the help of these settlers, we can expedite the process. So there are on the basis of types of filters, we can divide them into two basic parts. One is pressure filter, then there is vacuum filter. So pressure filter can be of air pressure type, having horizontal or vertical press system. Then there are tube press also. Then uh, there are mechanical pressure filters also, which use plate and frame filter press, like in between two frame or in between two plates, we are going to squeeze the material, so the water is going to get outside from that material. And there one more is there, that is called as chamber press. Then there are vacuum filtration processes which can be further divided into two different parts like batch filters and continuous filters. So batch filters are generally leaf filters and tray filters, and then continuous filters are rotary drum filters, disc filters, or horizontal belt filters. So the basic difference between these two systems are like in pressure filter, we are applying the pressure on the material so the water can squeeze out from the system. While in the case of vacuum filter, we are just creating the vacuum. So when we are going to create the vacuum inside a system, then what will happen due to the pressure difference between the two zones, the water will flow away from one zone to the another zone, leaving the slurry, leaving the slurry having very less amount of water in first zone. So there are some types of vacuum filters. Then drying of filtered concentrate. Generally, these filtered concentrates are dried in a rotary dryer, like at a temperature of around 180 or 200 degrees Celsius. So that can remove the water level up to 5%. And that material having 95% material plus 5% moisture content only, that can be processed in the further movement, or we can just transport it to some other industry for further processing. Then slurry or pulp mass percentage dry solids. There are some formulation. A slurry is suspension of solids in a liquid. Mostly we use water as a slurry system. It is also referred to as pulp. The concentration of dry solids in a slurry, or we can say percent solids, is expressed as mass of solids in slurry divided by mass of solids in slurry plus mass of liquid into 100. Or we can define this with the help of this formula, ms divided by ms plus ml into 100. Then if we are talking about the densities, let rho sl, rho liquid, and rho as the densities of the slurry liquid and solids respectively. So in a slurry of 100 kg percent solid, we can calculate it easily. what is going to be the percent solid inside this particular slurry. So based on this, we can solve this numerical. Then, so we have gone with the beneficiation processes. We have separated out the mineral and gangue material separately. Then after separating them out in some wet conditions, we have gone with the drying processes. After drying process, we are going to get our concentrate and gangue material, gangue mineral. So now we need to analyze the physical properties of that concentrate material. So during the physical properties, we are now we came to now when we are going to analyze the physical properties of that particular concentrate, then we came to know that let's say it is containing a very wide size range in that particular concentrate material. So we need to divide that particular concentrate according to the different size stream so that we can use them in further process streams. So for this thing, we generally go for the sieve analysis or various types of screen for differentiating the particular concentrate in different size ranges. So there are various methods of size estimations, first one is sieve analysis. So in the sieve analysis, the particle size can be characterized by determining the size of the sieve hole or aperture the particle will just pass through. So it is generally the oldest and most common method which generally used in the industries. Then there is sedimentation method, the time. So in sedimentation process, if the size of the particle is bigger, okay, so the free settling velocity of that particular particle is going to change as compared to the same mineral particle having different size. So based on this free settling velocity time period, we can calculate the size of the particle. The time the particle takes to settle in a fluid and express the particle size as the size of the sphere that has the same settling rate. That is known as generally for this sedimentation method. When we are going to analyze the diameter of the particle, we generally call it as Stokes diameter. Then there are microscopic methods like visual examination under the optical microscope, or we can go for electron microscopy or the diffraction of a laser beam to derive statistical dimensions of the particle. So there are different size methods for size estimations like static methods. Then there are dynamic methods. In static methods, we generally talk about the microscopy and diffraction methods, which generally include optical microscopy or scanning electron microscopy, or we can go for the laser X-ray process also. While in dynamic methods, we can go with sieving, centrifugal, or sedimentation or filtration processes for analyzing the size of the material. Then there are some equivalent size diameters of irregular particles. Then sieve analysis is sample material successively passed through finer sieves and weighing the amount collected on each sieve to determine percent weight in each size fraction. The sieves are usually agitated to expose all the particles to the opening. Presence of near-size particles can cause blinding or obstruction of the sieve apertures and reduce the effective area of the sieving medium. So, based on the sieve analysis, we can calculate the average size of a particular mineral. The sieve size analysis of a mineral sample giving the mass fraction of mineral retained between successive sieve sizes is usually recorded as in the table. Like we are recording the size as uh, minus 3500 micron and 1750 micron, then 1750 to 875 micron. So, minus size is for the passing and plus is for retaining. So based on this, we can calculate the average size of the particular material. Then in the industries, we use different types of screen for the screening operations. The screen is a surface having many apertures or holes, usually with uniform dimensions. Particles presented to a screen surface either pass through or are retained according to whether the particles are smaller or larger than the governing dimensions of the aperture. So generally, the sieve size is denoted as it in the term of mass size. So mass is defined as the number of holes, number of uh, holes which is having similar dia in particular 1 inch square area. So if there are 20 holes in 1 inch square area, then the sieve size will be no, will be denoted as 20 mass. While if we are having 200 200 holes in the 1 inch square area, then the sieve size will be 200 mass. So the sieve size is generally denoted in the terms of mass. So dry screening is generally limited to material above 5 mm in size, while wet screening down to 250 micron is common. Sizing below 250 micron is more commonly undertaken by classification processes like hydrocyclones or other things we can use for determining the size of the material. Then screen efficiency, often called the effectiveness of a screen, is a measure of the success of a screen in closely separating oversized and undersized materials. The particle size, feed rate, screen angle, particle shape, open area, vibration, moisture effect, effectiveness. These are some factors which affect the screen particular screen efficiency calculation during the process. Then there, based on the classification, we can divide the screens into two different categories. Like one is dynamic, then there are static screens. Generally, static type screen is generally used for the bigger size material. Like if we are trying to separate material having size of a basketball, or we can say 20 or 40 size, then we generally go for the static type screens process. While if we are talking about the lower size category, okay, so in that case we have to go for the dynamic type screens, which can help in increasing the which can help to increase the efficiency of the sieving operations.